A mosaic is an image cobbled together piece by piece. The whole is far more than the sum of the parts. So it's a fitting name for the MOSAiC research mission, which is about understanding the whole Arctic climate system by studying every different process, every component, and piecing them all together. Some of the pieces are people, the scientists, crew, and experts from different backgrounds all over the world. And some of the pieces are the environment itself. The months-long dark winters where sea ice grows, and the constant sun in the summer where sea ice melts. When all of these pieces come together, they begin to help us see the Arctic as a whole. And for the MOSAiC expedition, this is what we set out to do, to understand its changes and its future. The Arctic is the northernmost region on Earth. At its center is a frozen ocean surrounded by land. The northern parts of the United States, Canada, Greenland, Iceland, Norway, Sweden, Finland, and Russia. The Arctic Ocean may be the smallest and shallowest of the world's major oceans, but it is one of the most extreme and unique environments on our planet. Sunlit for one half of the year, and dark for the other, the region sees extreme cold, harsh storms, and periods of icy, stunning calm. To live and thrive in the Arctic requires resilience and passion. For millennia, indigenous communities have been calling the Arctic home. They are the keepers of knowledge about the lands, ocean, and ice. For hundreds of years, the Arctic has been a magnet for scientists and explorers around the world, seeking to understand this vast, remote region.
Far north in the high Arctic, the ice is constantly changing and constantly in motion. In the dark winter months, sea ice grows and thickens, while in summer, warmth and sunlight melt it back. The seasonal growth and melt is like the pulse of the Arctic Ocean. But the Arctic's pulse is changing. The region's temperatures have increased faster than anywhere in the world, and it is one of the world's most rapidly changing environments. Arctic sea ice feels that change, and it responds.
How does the ice respond? And do those responses matter for people who live hundreds or thousands of miles away? That's where MOSAiC comes in. The Multidisciplinary Drifting Observatory for the study of Arctic climate. Inspired by great explorers of history like Norway's Fridtjof Nansen, MOSAiC participants from more than 30 nations set out to conduct the world's largest and most complex Central Arctic research expedition. They capitalized on one key detail that Nansen had studied more than 125 years ago. Sea ice moves. Currents push and pull sea ice for thousands of miles across the Arctic Ocean, while the ice slowly thickens and splits, groans and moves with wind and waves. On board the German research icebreaker Polarstern, the expedition team sailed north of the Siberian coast of Russia and froze the ship into the sea ice. The team's journey begins in Tromsø, Norway, with the Polarstern packed with science instruments, safety equipment, helicopters, food rations, and everything the team will need to endure the Arctic's harsh elements. They search for the perfect ice floe, a large sheet of frozen sea ice that will help them observe the Arctic climate system.
We're studying the Arctic atmosphere, sea ice, and ocean system, looking at the chemistry, the biology, the physics, and importantly, how they all interact, cutting across the whole system. And so this requires scientists that look at things like the atmosphere and clouds, or maybe they'll go take a water sample and analyze it in a laboratory, or maybe they'll go and take an ice core and look at the physical structure of the ice. All these pieces working together. To observe the Arctic climate, you have to be embedded in the middle of it. And sometimes it's cold, it's dark, it's windy, it's snowy. Your fingers get cold, your nose gets cold. Sometimes you have to be waist deep in water. All these challenges, but this is really what it takes to be there and observe what's happening in the Arctic system.
Once they found the perfect floe, they began setting up research sites just in time to capture the first season snowfall and to get one final glimpse of the sun as it sets into the polar night. This months-long polar night happens because our planet spins around the sun on a tilted axis. So there are times when the north is constantly lit up by 24 hours of sunlight, and other times it's in total darkness. For months, the MOSAiC team can see the ice only in the cold moonlight and the warm glow of their headlamps. The frozen world seemingly so small in front of them as their flashlights bathe the ice in red and white.
In the Arctic during polar night is one of the most incredible opportunities and experiences because you really are this really small blip in this vast, dark, desolate, and cold expanse. And it's unlike anything I have ever experienced, and I think what so few people have actually experienced. You wonder, it makes you really wonder what type of life can thrive in these conditions.
The team studies many pieces of the Arctic puzzle to understand how they work together and create the Arctic we are seeing today.
The three key pieces of the MOSAiC are the physical, chemical, and biological properties of the Arctic system. Each piece helps us describe the matter that makes up the Arctic, the changes and interactions between the atmosphere, the ice, the ocean, and even how plants and animals move throughout the whole system.
As the air temperature plummets, so does the surface temperature of the ocean. A thin layer of water in contact with the frigid Arctic air dipped below 32 degrees Fahrenheit when fresh water freezes. As the seawater continues to cool down to 28.4 degrees Fahrenheit, needle-like ice crystals start to form. As more and more crystals form, they link together and spread across the surface. When sea ice coats the ocean's surface, everything changes. And this is why scientists are here in the dark and cold of the central Arctic Ocean's winter. Light fuels photosynthesis in tiny algae and other phytoplankton that are the foundation of the food chain. But how does life survive, and even thrive, here in the dark?
Answering our questions requires more than just looking at the physics or looking at the ocean, but it requires biologists, meteorologists, measurements of all different types cutting across the system so that we can put together the pieces of this big, complicated puzzle. Working in the dark, in the Arctic winter, can be really hard. It can be challenging because you can't see, because you're cold. But in the end, it's important for us to get these kind of measurements. We have to be there in this 24 hours of darkness to really understand the Arctic winter.
It's spring, and the sunlight begins to hit the high Arctic region again. For weeks, the sun slowly spirals up higher into the sky. The returning sun will not set again until the fall, bringing about the midnight sun. The sea ice also senses the return of the sun and slowly responds. Snow on the ice surface melts, crafting a topography of valleys and ridges. These changes in the icescape create new challenges for the scientists as they travel to their research sites. The melt season brings about changes to the physical, chemical, and biological interactions the scientists have been studying during the dark winter. The constant light from the sun warms the atmosphere, causing temperatures to increase. The energy from the sun travels through the atmosphere and to the ice and ocean surfaces. When sunlight hits the white ice surface, much of it reflects back to space. This reflection of sunlight helps to regulate the Earth's surface temperature and keeps the Arctic relatively cool. Darker surfaces, like the ocean, absorb a lot of the sunlight, warming the ocean.
Clouds also play a really important role here in that they reflect sunlight, which cools the surface, but they also serve as a blanket that traps heat near the surface.
Scientists measure surface reflectivity in two different ways. Some scientists measure the reflectivity in a single location to observe how the sea ice undergoes a massive transformation from a cold, snowy surface to an ice cover pocketed with melt ponds. Other scientists walk around on the ice floe to measure how surface reflectivity changes spatially, over the ice, over a melt pond, over the snow. These measurements are the key pieces of the mosaic that we are putting together to understand what drives Arctic warming.
Biologists and scientists associated with MOSAiC are on board Polarstern and working on the ice to collect all the different kinds of algae and animals living associated with ice and in the upper ocean. And we're doing this so that we can understand their life cycles and how they interact with one another, which may have an important role in understanding the linkages between the atmosphere, the sea ice, and the ocean. A lot of these organisms are really, really small, and you can't see them unless you use a microscope. But even though they're small, their diversity is so great and their numbers are so large that they have a real impact on understanding Arctic climate.
The sea ice melts both from above and from below. Above the surface, the increased atmospheric temperatures transform the ice. Fresh water begins to pool on the ice surface. These pools absorb more sunlight, driving more melt, transforming the icescape into a vibrant, colorful world. Scientists from different disciplines monitor changes of this summer transformation from unique perspectives. Some drill into the ice and pull up cylindrical cores. Biologists look for living organisms in these samples. Physical scientists study their structure. These cores of ice help tell the history of how the sea ice grows, melts, and refreezes throughout its lifetime. Other scientists measure the rate at which the ice melts using stakes drilled through the ice.
Sometimes melt season means big melt ponds that can melt all the way through, meaning the fresh water comes into contact with the salty ocean surface. And as this fresh water is less dense than salty seawater, it floats on the top, and you get this layered system that creates a really unique environment for the things that live associated with ice and the upper ocean. And what we can see is that this barrier of fresh water against salt water creates an interesting layering of the organisms that live there, like sea ice algae and plankton. And the reason we're so interested and intrigued by this cool environmental phenomena is because that structuring has an effect on the environmental conditions that things like plankton and zooplankton require. So it changes the way that light interacts in the Arctic climate system.
After months of melt, the ice is thinner and covers less of the ocean, both in thickness and in spatial extent. As the sun slowly sinks, the atmosphere, ice, and ocean cool. Life in the Arctic prepares for the disappearing sunlight. as the darkness engulfs the Arctic once more. The yearly pulse in the Arctic starts again. The MOSAiC expedition has completed its full year in the Arctic. It is time for a bittersweet goodbye. The mission is far from complete. The MOSAiC team brings back a treasure trove of data and memories of the vast icescape. This is MOSAic's legacy, the most comprehensive, multidisciplinary dataset collected from the Central Arctic climate system. A resource for generations to come.
What has been so intrinsic to our success has been the community of persons that have built this program. I think about what we've accomplished together, and it's hard to ever think of that without thinking about the people who devoted their time and their energy and their hearts to everyday tasks. At the end of the day, science isn't something you do on your own. It's something that you build and create. And if you have the opportunity to build that and create that with others, it just makes it so much more meaningful in the process by which you build, but also in what you create together.
We needed to be there. We needed to record the details of this changing pulse of the Arctic system. Indigenous people have been recording that pulse in their own ways for millennia. Arctic changes are already affecting Native communities in serious ways, and we are just beginning to understand how changes in this region affects the world too.
As I consider the past, present, and future of the Arctic, I can't help but think about how much the Arctic has changed and how much it'll continue to change into the future. We still have so much to learn about the Arctic and the transformation it's going through. And with MOSAiC, we've been part of that story. We've been embedded in the middle of it, and we must learn from this experience and share it with the rest of the world. We must continue to ask questions and seek the answers to those questions, and we must continue to add pieces of understanding to the Arctic MOSAiC.